So today our big lesson is finding the equation of the tangent line. Remember that when we find the slope using the derivative, we're really finding the slope of a straight line that hits the curve at that point, right? Because when you have curved lines, the slope changes everywhere you go. So that's what we're using the derivative for, is to find a slope at a given point. And that point is always an x value. So I want to recap a little bit and just talk about what we've been doing, okay? First of all, we've been using the derivative to find slope at a given point. Yeah? So that's what we've been doing so far. And we do that because that gives us the practice that we need to be able to just develop our ideas about the calculus and about the mathematical system itself. Okay? Now, a couple of things that we've looked at. We've really looked at only two things. The first one was, if we know the x value. Right? So they say, find the slope. They give us the function. They have to give us the function, right? They give us the function, and they say, find the slope when x equals 9. Right? So remember, what we did was, we took the derivative by multiplying the coefficient by the exponent, subtracting 1 from the exponent. Right? So that part is really easy math. And then substitute x value into the derivative to find m. And m, of course, just stands for slope. Also, this book likes to call it gradient, right? Okay? Gradient, slope, m means the same thing, right? So that's what we did at the very beginning. Then yesterday what we did was, we did the same thing, but when we know not f, but we know the y. Okay? So when we know y, otherwise known as f of x, right? Remember that y and f of x mean exactly the same thing, right? Or it even has another name. But we'll see in a minute when you're dealing with that. Okay? After you take the derivative, we'll talk about the different ways. So remember, it can be written as, your function can be y equals something, or f of x equals something. And both of those mean exactly the same thing. Okay? So if it says f of x, you know that means a y value. If it says y, then you know that means a y value. Okay? So that one is the one we looked at yesterday. So in order to do that, what we have to do was first substitute in the y value, solve for x, because remember, we're trying to do this. This is our basic idea. So we can't find that slope unless we know which value. X, right? And so if they give us a y value, we have to use that y value to find our x value. Okay? And that was what we did yesterday. Then take the derivative, find slope by substituting the x value into the derivative. Yeah? Sound familiar? So kind of boiling it down. So what you do is going to be dependent upon the information that they give you. Okay? So some of you were having a little trouble putting all of it together yesterday. So I think that might help you a little bit. Okay? Yes? Sure, you may. And of course, it's being recorded too. Okay? All right. Now, so yesterday, we were working on these. So let's talk about any of those that you have questions about. Do you have some questions from some of those that you did for homework yesterday? How'd they go? If they went, right? I know that sometimes you get busy, right? If it's a whole day, if it's only one day between classes, I understand that many times you're not going to be able to get to it. But at least try to get one or two done so that you know if you have some questions. Okay? Yeah? No? Okay? All right. Well, then let's move on to what we're going to do today. And I introduced a little bit of this yesterday, but we're going to talk about it. Today what we're going to do is we're going to look at how to find the equation of that tangent line is what it's called. The line that has that particular x in it that gives you the slope at that particular point. Okay? And we mentioned yesterday something called the point slope formula. This is one of those algebraic formulas that you need to know in order to be a good algebra student. It's just the only way you're ever going to make a good algebra student is if you know this formula, because it comes back to haunt you everywhere you go. All right? But it's called the point slope formula. So what do you think you need to know in order to use it? Exactly. Yeah, you better know the formula too. Must know a point, right? And remember, a point has an x and a y value, yes? We must know the slope, also known as gradient, which we always use the letter m to stand for slope, right? And of course, yes, you must know the formula. The formula is y minus y1 equals m times x minus x1, where x sub 1 and y sub 1 are the x and y values from the point. Now, you always going to have both of them? No. But if I know x, I can find what? Y by simply using substitution. If I know y, I can find x. Yeah? Does it make sense? And m is the slope or gradient. Okay? Now we'll talk about the process that we need, but I just wanted to kind of remind you of that formula and which pieces come from where. If you put them in the wrong spot, you're going to get in trouble because you're going to make a lot of sign errors. Okay? All right. So we're on page 22 in your book, if you want to follow along. And let's just look at a few of these examples. They're going to give you some things. So look at example 1. So they give you the formula. It says, find the equation of the tangent to the curve y equals 3x squared minus 2x plus 4 at the point...
Oh, I thought that said PZZ, and I was like, what?
Page 22. 22. Okay. At the point 1, 5, right? Okay. Now, in order to find the equation of a line, that's always the same formula, no matter what you're doing. That's y minus y1 equals m times x minus x1. And I know an x and a y, but what am I missing that I need for the formula?
Slope.
The slope. But it's easy to find the slope. So step 1 is find m. Now to do that, first we'll take the derivative. Right? This is not new, but I'm just writing out what I'm doing. So dy dx, 2 times 3 is 6, x to the 2 minus 1 is x, 1 times negative 2 is negative 2, the x disappears because it becomes x to the 0, and of course the derivative of the 4 is 0. So there's our derivative. What's the next step in finding the slope? Substitute the x value. So we get dy dx equals 6 times our x value, which is 1, minus 2. Okay? Which gives us a slope of 6 times 1 minus 2 gives us a slope of 4. Yeah? Nothing new there. That's exactly what we did but back in the day, before we went on vacation. Okay? Now do I know a point? Do I know the slope? Then I can use that information to find the equation of the tangent at that point. Now again, this is not the equation of the line that has that of the curve that has that slope. This is the equation of the line that hits that slope. Okay? And you're going to see why it's important later when we start doing some applications.
I was thinking it was like, when you're doing the derivative stuff in the equation that you start with the Taylor derivative. I thought I was trying to find that. So I was like, what?
Yeah, so like we have our curve, and remember yesterday we drew those little lines, like there's just the line that hits the curve like that. That's the part we're finding. Okay? All right, so y minus the y from the point, which is 5, equals my slope times x minus the x from the point, which is 1. So y minus 5 equals 4x minus 4. Add 5 to both sides gives me y equals 4x plus 1. And that's the equation of the tangent line. So that's all you're being asked to do. Okay? So solving a simple linear equation here. Always give it in that y equals mx plus c format. Right? In other words, solve for y. Okay? All right. Now, remember that we can do that easily when we're given the point and the slope, but we can also do it when we're just given one part of the point. Okay? So look at example 2 there. So f of x is equal to x to the third minus 2x. And we want it at the point where x equals 2. Well, in order to do that, remember I have to use the point-slope formula. So I need to know a point, and I need to know the slope. Well, I know an x value for the point, but I have no y value. And I also have no slope. Okay? So I'm going to have to do two things. First of all, I'm going to have to find the y value. But I can do that easily by simply putting the x in and solving it. So f of 2 equals 2 cubed minus 2 times 2, which gives us f of x, which is the same as the y, right, is 8 minus 4. So f of x is equal to 4. So that gives us our y value. Right? And if you want to change f of x into y to work that, that's perfectly fine because that's what you're looking for. Right? Now that I know the point, now that I need to find the slope, in order to find the slope, I need to first take the what? Derivative of our original function, right? So f prime of x equals 3 times 1 is 3, 3 minus 1 is 2, 1 times negative 2 is negative 2, and x to the 1 minus 1 is x to the 0, so the x just goes away, right? Now we're going to substitute in our what? Our x value, right? Because it's all in x, yeah? So f prime of 2 is 3 times 2 squared minus 2. 2 squared is 4. 3 times 4 is 12. Minus 2 gives me a slope of 10. We all good? Now, just substituting that into the formula. Y minus 4 equals 10 times x minus 2. Y minus 4 equals 10x minus 20. Add 4 to both sides to get the y by itself. Gives you y equals 10x minus 16. Dead easy, mathematically, right? Your issue is to know when to do what. And that's often the case in calculus. Calculus is easy math, oddly enough. It seems like it doesn't make any sense, but it does. The mathematics in the calculus is quite easy, but you have to know when to do what. That's the big deal. Okay? So you guys ready to do one on your own? All right? So let me get you one. We're going to do one of each of them so that you know what we're doing. Now, I'm going to mess with you a little bit here. Of course, you know me. All right, so let's do number 6 on page 23. G of x. Does that matter that they're not saying f? No, who cares? That just means some function. Equals x to the third minus 2x squared plus 1. And we want the equation for that at the origin. Okay? What do you think? You need 3 minutes? How about we do 3 minutes and we'll see what's going on. Go. So, there you are. Find the equation of the tangent line at that point. Okay? So, we know we needed the formula. We knew our whole point because it was the origin. We took the derivative, found the slope, plugged that information into the formula to find the equation. Yeah? Okay, let's do another one. Same page. Let's see. How brave are we? Do we want to do 10 or 12? 12? Okay. Good deal. Y equals x times x plus 1. It's all right. Times x plus 2. There's going to be a little multiplying to do. Oh, that one's a cheaty. It's giving you a point. I don't want to do 12.
I've already written it.
We can unwrite it. And you've written it in ink. Well, that's all right. Oh, look at that. See? Doggone it.
Just change it.
Doggone it. It fell apart. All right. So let's do
Change it on the go.
let's do number 8. Because number 8 has something in there you've got to be very careful about. Okay, there you go. There's your question. You got 3 minutes to work on it. Again, remember, you're just walking through doing exactly the same thing that we did last time. Okay, so let's just do. So our steps were: first, find the y value by substituting the x value into the function. Then find the slope by taking the derivative and then substituting the x value in to find the slope. And then substituting all of that into the point slope formula to find the actual equation of the tangent line. A lot of busy work going on, right? But again,